come to a basic brief idea about what is algorithm. An algorithm is a finite set of instructions which accomplish a particular task. That's it. There is not much complexity involved into this one. It has some input. It will definitely give some output. It will have a definiteness, finiteness, and effectiveness. Let us understand first effectiveness. What exactly effectiveness means? It means that whatever the work it is doing, it is utilizing the space and time very effectively and efficiently. It should not take a lot of space in memory. It should not take a lot of time. So an algorithm is generally very effective. Otherwise, it is just another set of instruction which is not a good algorithm. So a good algorithm will have all of these properties. Now what is finiteness? Finiteness means that set of instruction will work in a finite unit of time like 5 minutes, 10 minutes, 5 hours, 10 hours, or in a finite duration. It will not go into infinite loop. It will not go into never ending process. It will not go into undeterministic way that when it is going to end, nobody knows. So that should not happen. So a nice and good algorithm will definitely have input, output, effectiveness, very efficiently using the memory and time. It will have a finiteness. It will complete its task in a finite unit of time. And there is an important part called definiteness. What is definiteness? What it means is that for a given input, it should always produce the same output. It should not happen that whatever input you give, the output will be completely undeterministic. You never know what the output will be. So there is some kind of a definiteness which says that based on the input, this will be the output. Okay? There are some small cases where this definiteness may not be there, especially when you have a random and secret key generation and those things. But if you leave those certain cases, in majority of the cases, definiteness means that for a given input, you should expect the same output from the algorithm. So those are the basic property of an algorithm. Okay, there is not much complexity, very simple, and we'll understand like that. Why it is required, first of all? Why do you think that we need an algorithm? Do you really need an algorithm? Why do you need an algorithm to become a software professional or software developer? Well, despite the growth of the technology, despite the fact that we have a very fast microprocessor, we have lot of hard disk, we have lot of RAM, we have lot of CPU, on the other side, the computational challenges and requirements are also growing. So along with the hardware and the system becoming faster and faster, our requirement of the system and the society to compute things faster and faster is also increasing. So it is always good that we can solve a problem in faster and better way. And that's why we need algorithms, so that we can solve a problem in much efficient and better way. If we don't have a good concept in algorithm, then you will solve the problem, but it will not be very efficient. It will be very, very inefficient. So at the end, you will get the result, but the time and space it will take, it will be huge. And for a small case, it might not be visible, but think about a case where a particular program takes, let us assume, 0.001 millisecond more. Then you might say that what is a big deal about 0.001 millisecond? But think about that program running thousands of millions times every day. Now over a year, that delay might become something like a week or 2 weeks or month. Now if you can save a month or so, it is a big saving. So that's why we have to understand that there are some cases where performance and efficient use of space and memory is very important. Let us see one example. Let us assume that I want you to write a code that will shift data 50 to 98. Let us assume that you have an array data, and in that you are storing some information from data 0 to data 99. So here is data. The index is 0 to 99. Okay. Now what I want is that in this one, I want to shift everything which is in data 50 to data 98 one step, one index further. Like whatever is stored in data 50 will move to data 51. Whatever is stored in data 51 will go into data 52. And like that, whatever is stored in data 98 will go into data 99. And then finally I want to insert a number called 42 at location data 50. Now for this I want you to write a code. This can be written in multiple ways. If I give this, it is a very simple problem. Try to write it. Just see that how you will write the code. And once you are done with this code, analyze that code. Is it very fast? Is it the best way to write that code? Now if doing such a simple thing can be done in a very efficient as well as very inefficient way, then think about large number of programs which we write in the software world, which can be written in efficient and inefficient way. So I would suggest that try this. Try yourself before you see the solution. Now next problem is that write code to add numbers from 1 to n, where n is the any number input given by the user, and try to write this code. What is the best way to write this code? You will write a for loop for I equals to 0, n, and sum equals to sum plus n. But is that the best way to write the code or most efficient? No, maybe not, or maybe yes. Think about it. Next is that write the code for Fibonacci series using recursion. Now this one, how do you use recursion so that you can write it more efficiently? Now try to write the code in most efficient way for the above cases. Once you have done this exercise yourself, let us go and check what is the one of the better way to write the code. Now first one is that code for shifting. The simplest and fastest way to complete that exercise is this. This is a 2-line of code, just 2 line. Think about. I solved that problem by writing 2 line of code. For I equals to 99, I is greater than 51, I minus minus, data I equals to data I minus 1, data 50 equals to 42. Now if you have written the code which is as efficient as this, then you have done a decently good job. If not, you have done something different, then that code is not very efficient and not a very good algorithm. Now, how do you add a number 1 to n? You can use a do loop, or you can do a simple formula, one-liner called system.out.println n into n plus 1 by 2. So in one line, it will add all the number from 1 to n and print for you. You don't have to do anything. Now, isn't that much efficient than doing a do loop? How do you write the Fibonacci series? Here is an example of how to use a Fibonacci series in a much better way. So these code samples are just to give you an idea that you can solve a problem in a efficient way or inefficient way depending on how you want to solve the problem. So either you can solve it in a very efficient way or you can solve it in a very inefficient way. Okay? So it is up to you how you solve the problem. Now let us see one example of algorithm. Here we will try to find the maximum of three numbers. An algorithm for this is given as below. Finding the maximum of three numbers a, b and c. So that is the input a, b and c and output is x. What I am going to do is that I will take a temporary variable x equals to a. If b is greater than x, x equals to b. If c is greater than x, then x equals to c and return x.